let's start by talking about what's on this test. Who can tell me what was 1.8 and 1.9? What was 1.8 and 1.9? Think back to your problem sets you worked on over the weekend. What was 1.8? What was 1.9, Kate?
Word problems.
Yeah, word problems. Okay, primarily word problems with equations involved, with equations, not with inequalities. 2.3 is also word problems, but with inequalities. So what should you expect on this test? A lot of word problems, okay? It will happen, okay? It's not unusual. Does anyone have a hard copy of their problem set? I will take that before the class starts, please. Just bring it up or give it to me. Perfect, thank you. Names on all pages and all that stuff, Tristan? Good, good. Anyone else? Hard copies? Yeah, go ahead, finish, put your name on. Here, just pass it up, just pass it up. Don't. Yes, thank you, Ash. Nice. Good name, good. So I mentioned this last time. If you're going to do hard copies, I'd prefer you to give me the hard copy and keep a picture of it yourself. Did you take a picture? Do you want it to study tonight, or are you okay? Okay, how about you? Do you want a copy of yours to study with? You good? You want a picture of it right now? If you do, take a picture of it later. If any of you guys want to combine, take a picture. But did everybody submit it, honestly? Anyone not get a chance to finish? Be honest. Tell me the truth. You didn't get a chance to finish. Because I'm going to check next period just to make sure everybody put it in Drive at least. And if so, I'll put out the solutions. So you really don't need a copy of yours if I'm going to put out the solutions anyway. So as long as you guys keep up with your end of the work, I will put up the solutions. If one person didn't do it, though, I won't put up the solutions. Okay, and there are 2, 4, 6, 8. Okay, we're all here. That's good. 10.
It's so cold. Can you talk to somebody to turn on the heat?
It's chilly in here?
The entire school is cold.
I know. See, is this even on today?
It's literally freezing.
It's not even on.
Because they haven't switched the AC to hot.
Yeah, I'll ask the maintenance department for sure. I'll mention it, guys. It's one of those things with a school like this. Even last week we had there was a heat problem with one of the gas valves, so it was too hot downstairs instead of too cold. So the commons was really hot. All right, so let's take a look at this. And by the way, for those with short sleeve shirts, just FYI, Miss Coop's gonna have no mercy for you, which I don't blame her, because at this point in the year, you can either wear a shirt and tie or the polo. So if you're cold and you have a polo, she's gonna say, wear a sweater. Okay, that's what she's gonna tell you. So the Loyola sweater, the V-neck with the thing, is what the students will wear over their polo a lot if they're cold. So if you want to, your Loyola sweater, it's supposed to be dress code, okay? So make sure you get that one. Bring that in. I mean, it'll be just more comfortable too. Yeah, it might be useful to help. And then what about 2.1 and 2.2? What was 2.1 and 2.2 all about?
Like inequalities.
Yeah, solving inequalities. And some interesting solutions to them were all real numbers, or no solution, or conjunction and disjunction, or an and. So what I'd like to do today is just maybe go through a few examples of it and take some of your questions first. Anything that you've been struggled with or struggling with on the problem set that you want to go over?
So for some of them, I think it's or, it's supposed to be disjunction. But I get them connected. Is that
And they end up going this way?
Yeah.
So that means you're making a mistake somewhere along the way. So let's look at an example of that. Let's say we've got, I want to pull up a good example that I know the numbers work for it. Let's say, here we go. We've got negative 12 less than or equal to 5x plus 1 less than or equal to 16. Well, let's just go with less than in this case, actually. All right, so that's our setup. Now, as soon as you see the setup, what do some of you think? What do you think when you see the setup? What's the first thing that pops in your mind? First thing that pops in your mind?
Just minus 1.
Yeah, get rid of the 1 on both sides, on all three. Now, how about something that pops in your mind about the overall problem, not the solution to getting it? Overall problem, what do you think?
Isolate
Isolate x. Good. What else? What else do you think of when you have an arrangement? I think of something specific. It makes it a lot easier for me. When I see this, I think of an and statement automatically. Here's the reason. Let me explain. Look at the orientation and then look at the signs. There's no negative sign here, correct? So are you going to have to flip the directions? No. So you know already that the directions aren't going to have to change. And because you have a number on each end, you're going to end up with x in the middle and a number on each end. That's an and statement always. Always an and statement. This is a compound inequality, specifically a conjunction. So I think of an and statement as my solution, and I think of the fact that the solution on the number line, they're going to overlap. They're going to come together. This is not going to be one where they're going to move apart. That's what I see already from the problem alone. Forget the answer, but just actually seeing what's happening. Then, yes, start moving stuff around. Now remember, get x by itself. To get x by itself, you need to get rid of whatever's near it in all three parts, not just in two parts. So get rid of the 1 first. Oops, I need a... Okay, 15, negative 13, 5x. Okay, that's what I've got. Get rid of the 5 by dividing. Okay, and that's my solution. I'm done algebraically. I'm absolutely done. Unless I ask you, what is the answer in interval notation? What would that answer be in interval notation? Remember, that's solution set form. How do I write that answer as an interval notation? Think about last class. We spoke about this real quick. Annette?
I'm not 100% sure, but it's the squarish bracket. I don't know what to call that.
Bracket.
And then you have negative 13 over 5, and then comma 3, and then a parentheses.
Very good. That's exactly right. Good. So this ranges from negative 13 fifths to 3, including negative 13 fifths. Tristan?
Yeah, I mentioned.
Okay.
Did I know the test?
Interval notation?
Yeah.
You should be familiar with it. I may not directly say write it that way, but I may put it in a multiple choice where you need to know what that means, right? So the actual notation should be familiar.
What's that other one called now?
So this is solution set form. Right there. That's what solution set form is. So solution set notation, interval notation.
In the test, when you saw like this thing, do we have to like write the solution in solution form, or do you just?
Well, you're going to always get it in a solution form in general, and then you're going to plot it on a number line to show your answer. So the number line is really your solution. I mean, we haven't gotten to that for this problem yet, but this is what you would do afterward, right? So negative 13 fifths, 3. Now this is going to be a closed circle. This is going to be an open circle, and we're going to shade everything in between. Okay, so that really dictates what's going on, but you should have one of these representations, at least one of them, and a number line. Okay? Again, if you got confused about whether this was an and or an or statement, just think about it, right? So I want you to break this up here. I'm going to circle a part of it. How would I read that? What's circled right there? How would I read that out loud? Just read it. X is less than 3. Okay, agreed? X is less than 3. Now read what's circled in blue. Good?
X is greater than or equal to negative 13 fifths.
Yeah, so this is like a negative number, right? Say negative 5. Doesn't matter what it is. So X is bigger than some negative number and less than some positive number. So it's between some negative number and some positive number. What does that mean by between? You shade right between the two. So try to read them as separate pieces. Read this and think to yourself, should the answer be or should it be and? Does it make sense to be or? It wouldn't make any sense. How could a number be less than 3 or greater than negative 13 fifths? Or if you had another sample in a moment, we'll see where it has to be an or statement. If you try to write those as an and, it doesn't make any sense at all. For example, let's say we had this. Well, let's just go to another one. Let's say we had negative 2x is less than 12, and x is, so let's say or x is less, or let's say 3x is less than, I want to make this work. There should be a negative up here, and let's make this negative 15 right there. Take a look at this thing. So you got negative 2x less than negative 12, or 3x is less than negative 15. Now, the word or is there already for the or problem, so you're going to know off the bat and you don't have to worry about it. But if you actually solve these independently, what would you get for the first one when you solve this first one? What do you get when you solve the first one? Yeah, x is greater than 6. Why is it greater than? Why isn't it less than? Because you
Divide by negative.
good. Divide or multiply by negative, switch the direction of the sign. And then the second part is going to be x is less than. Yeah, and why don't I make that a greater than? Why didn't I switch that sign? There was a negative. Look, it's a negative right here. How can I switch the sign?
You did divide or multiply by a negative?
You divide into a negative, or multiply into, or by another one. Again, this is the number that needs to be negative to switch the sign. So x is greater than 6, or x is less than negative 5. Think about that physically. Here's your number line. Here's negative 5. Here's 6. Greater than 6 means this. Less than -5 means this. So it must be going in opposing directions. It's not possible to use the word and. Try to use the word and there. Can you give me a number that's greater than 6 and less than -5? No, you definitely can't. Okay, there's no number that's greater than 6 and less than -5. It does not exist. So this is most definitely an or statement. Okay? Other quick tidbits about inequalities. If you get an answer that everything drops off, let's say this is the problem. This is way too easy, and this would be not on your test this easy, but let's say that's the line you get to at one point in time. So you get this, and you say the following. 4 is greater than -2. What statement do you make as a result? What statement?
All real numbers.
It's all real numbers. Why?
Because any number could work in that situation.
Exactly. If this is true, then plugging in any number up here will also be true. Any number. It doesn't matter what. Try 0. Oh, look at that. Plug in 0, you get literally this. And it is true. So this answer would be x is any number, all real numbers. Remember that notation? You don't have to use that at all. You could just write x is all real numbers. How would you show that on a number line? What would you do on a number line? Yeah, you kind of just shade the whole thing. Okay, you kind of shade the whole thing like that. Hey, do me a favor. Try to be neat with your work. Some of your number lines and some of your work sometimes gets really sloppy. I had your quizzes, right? Didn't I give you a quiz last week? Can I give those back to you? Because some of you had trouble reading, actually. You'll see why.
I did so bad.
I got the first one right. I don't know what it is.
So here's some homework and quizzes, both. Homework. 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 Homework.
A checkmate.
I do. I looked to see if you did all the problems for the most part. I don't believe the answers right though, ever. On your problem sets, they're graded if the answers are right or wrong.
Check means like good or
Check means you got 5 out of 5. If you ever see anything less than a check, it means that you got less than that. I'll put the grade if it's less than that. Guys, don't ask each other grades. Doesn't matter. Come on. I want you to see what you did wrong. Look at what you did wrong. What was on that? Again, some people I gotta be honest, I struggle with reading a lot.
Yeah,
You gotta use pencil too. When you make a mistake, erase it. A little bit with this too. And I'm not really sure. It's kind of difficult to read that, so maybe putting a number line with just the one solution in there would be better. But I understood it actually, but I had that really great original sheet. Yeah, so you got 6 out of 6. Originally she was going to take up the point because she was saying the answer is really from here to here, which is true. So you should make sure you put that little bracket there to show that that was the overlap. So your final answer really should just be from here to here. So the overlap is to show you how to do it. The final answer should close circle, open circle. That make sense? Yeah, oh, here. Honestly, I'm not sure. Maybe it was this. Is this supposed to be shaded? I'll give you a question. When you shade it, this is enough. Maybe she was like, did you cross this off? Is that
No,
not
that's
what it is?
very
Yeah, I'll change it. Yeah, just be careful, okay? Other questions and stuff? Read what I wrote at least, make sure it makes sense what's written there.
it doesn't make sense to me why that's not a story.
Just look, you divided by -2. You forgot the negative there. That should be -2, and that should be -2, isn't it? You divide by negative, flip the sign. Part of the mistakes I'm seeing are careless, and I don't mean careless and you don't care. I use the word careless to mean like you can find that mistake if you check it over kind of thing. But to check it over, you have to work through your work efficiently. You're not going to have time to check it over if you don't get through your work pretty quickly. Let's move on to word problems then, okay? Can we do that? Are we good with inequalities? Yeah, go ahead.
I have a question on
Yeah,
profit.
Yes,
go for it. Is it a word problem?
Yes.
Awesome. Can you read it to me, or can you just tell me what problem it is? I have books right here.
15.
What section?
1.
1-9 or 15?
And now I'm realizing that I could have just checked the answer.
You definitely could have just checked the answer. What was the answer for number 15?
Wait, I did check. I got no solution.
What number?
This is number. Hold on. I'm on section 1-8. That's why. John drove part of a 206 kilometer trip. That one? This one?
I didn't know that one either.
All right. Let's draw it. Let's draw it. So John drove part of a 260 kilometer trip at 80 kilometers an hour, and the rest at 100. So here's what I start with. Ready? Here's what I start with. I don't know if this is drawn to scale. I don't care. It doesn't matter. What I know, though, is that this entire trip is 260 kilometers. So far, so good? That's what I start with. It says that John drove part of the trip at 80 kilometers an hour. And the rest of the trip at 100 kilometers per hour. So notice I use variables. What does R stand for in math? Rate. You could use velocity and V, and you could use distance. That's fine also. I don't mind that. Or speed for S, that's fine as well. Okay, but the general formula, if you remember, is this. D equals RT. Distance equals rate times time. And that makes sense. If your rate is 50 miles an hour, for 2 hours, you go 100 miles. Just multiply them. Let's see what it says. Find the distance he traveled at 80 kilometers an hour. At 80 kilometers an hour. So find this distance, D1. Let's write that down right away. That's what we're looking for. I'm going to give subscripts. See the subscripts? Why am I giving subscripts? Because there are how many parts? 2 parts of the trip, right? The beginning and the end. So I need to designate. It's the first part, second part. So we want to figure out the overall distance in the first part if the total driving time was 2 hours and 30 minutes. So this is the information I know. And you're saying no solution, or the book told you no solution?
So I actually did.
You put no solution.
I put that too.
Well, let's see. You have enough. Here's how I would tell. There's a simple way to do a problem like this. The way to do it is to look at your time equations. So you know that the total time taken would be 2.5 hours, right? Do you all agree with that? So I could say that the time it takes to go to the first portion plus the second portion will equal 2.5. Would everybody agree with that statement so far? Think about it logically. The time for the first and the second add up to the total time. Now, what is T1? How do you solve for T? Solve that equation for T. Go ahead. Solve it for T algebraically. What does it become? T equals? Look at the top right. Top right. So T equals? D divided by R. Come on, guys. We did this. We did this in section 1-7 or something like that. D over R is T. So D1 over R is going to be the time for this first portion. But we don't know what D1 is yet. Right? We're not sure what that value is. So we'll leave that as D1 for now. We'll write this as D1 over the actual rate itself. So again, D over R is what time is. The rate in this case was 80. Again, D1 over R1. What should go here? This was D over R. D1 over R1.
D2 over T2.
Not T2.
100.
Oh, over 100.
Over R2, the 100.
RD.
So I have a feeling that a lot of you at this point said, oh, there's 2 variables, I can't do it, right? Is that where you said not enough information? There's one more piece we could utilize still.
Well, you could.
It's like common sense, like, if you go at the faster speed of 100 miles
use
for
the
the
rate
entire
or-
time over the 2.5 hours, you can still only go 250 kilometers, so there's no solution as well.
Oh, you're saying no solution, whereas a moment ago we were talking about not enough information. So those are 2 different things. We can try to get a solution, and there may be no solution, but there's definitely enough information to try and solve this. There is enough information. We have one more piece of info we haven't used yet still. That's what we're trying to get to. What's the one piece we haven't used? You're right. The total distance. No, the total
Oh, yeah,
distance.
total distance.
Yeah, we know nothing about the actual rates, about the overall rate there.
Is that extra information?
It's not extra information because we can write D1 and D2 in terms of each other. What should D1 and D2 add up to? Right? Are they 260? Isn't this piece of information we haven't used yet? So think about D2. Can I write D2 in terms of D1?
Yeah.
Solve this for D2. What does D2 equal then?
260 minus D1.
260 minus D1. Again, look at this equation right here. D1 plus D2 is 260. So 260 minus D1 is D2. So this D2 can be replaced with 260 minus D1. Put that right there. Now you can at least try to solve. If there's no solution, it's very possible. And you said, George, by using logic, there is no real solution to this. I'm assuming you're right, but can we check to see? How would you solve this? What would you do to solve a problem like this then?
You just do number stuff, like,
Do number stuff. Let's do number stuff, people. Come on.
I like that.
I like that. New number stuff. So how about move things around, find out least common denominator, stuff like that, right?
Yeah.
Okay, so 80 and 100. What's your least common denominator going to be? 400?
Yeah.
Agreed? 400, yes? Okay, we could do that. All right, we'll do that for now. That might be the easiest way. So let's just make everything 400. But it's going to get really messy to make everything 400. So what I would personally do, honestly? I'd probably multiply by 10 or 100 everywhere, actually, instead of 400. Just to clear the zeros for that. Like, watch what I'm going to do. I just happen to see this. It's not like something that you're going to necessarily always know to do. But here's what I'm seeing. That might make life easier. Because 100 over 0.8, 100 over 80, I can write as a decimal, right? It's a little easier to do it this way, the way I'm doing it. 400 works, but why go to 400? There's no necessity. So the 100 times the 2.5 is going to give me 2,500. Or 250, sorry, 250. Where's my eraser? Oh, you gotta be kidding me. I always select the highlight tool and it never works. 100 over 80 is gonna give me what? 1.25? 100 over 80 is 1.25. And then when I multiply through this 100, it goes here and it also goes here. Well, this becomes 100 over 100, those cancel. So this is just plus 260 minus D1. Not DI, D1. No, it's not Notability. It's a different program. So it uses spatial things for like erasing. It's not like you select the item and it just moves away. I know, I wish it was. But the presentation part of this program is really nice, so I use it. So at this point, you would try to solve. And let's see what we get. And George used common sense, I think, and he got this number of 250, right, George?
Yeah.
And you were like, that's less than the 260 already anyway. And that's where that 250 is coming into play. You'll see there it is. If we solve this, 1.25d minus d gives us just 0.25d, d1, it doesn't matter. And then when you move the 260 over, you're going to get equals negative 10. So in this case, you're going to end up with a d value that ends up being negative. So you're right. There's going to be no solution to this problem. You're going to end up with d1 equals negative, what is that going to be, negative 40? Right? Negative 40? And that's in meters or feet or miles or whatever this was in. Was this in miles?
On the test, where should we decide, there's no solution?
Well, if you use logic and you write out your reasoning and it makes sense, that's fine. So if George had written a statement that explains all the reason behind it, fine. But the mathematical portion is really what proves it. So if you can make that statement prior to the math and it's correct, you get full credit. But if you make an arbitrary statement saying there's no solution, you give no explanation, your explanation is wrong, then it's not going to be given credit for.
What was George's explanation?
Why don't you explain it again, George? I'll write it as he explains again.
Okay, so no solution because even if John
Question.
drove 2.5 hours at the faster speed of 100 kilometers per hour, he'd only have traveled 250 kilometers.
Think about it for a second. Even if he went the faster speed the whole time, he'd only be able to get 250 miles covered or kilometers, whatever it is. So it's not possible to even think about it. Right? If the other portion is 80, it's got to be less than this.
I didn't even think about that.
That's a great, but see what he's doing is he's using like a sensible approach, you know, or a inspective approach. He's inspecting the problem. You would say like solving by inspection in math is a term. It just means like you're solving by looking at the problem, understanding the nature of it, as opposed to really going into a lot of the math of the problem. Other questions on the problem set? Word problems. Specifically, I'd like to do word problems if you could, just so we can practice for the word problems. What number is it?
32 on 2-2.
It probably was not because it was 2-2, but let's take a quick look. We can answer it.
Yeah.
Remember, 2-2 on 32. 2-2 on 32.
I got R equals.
All right, so we got r minus 3 over 6 less than or equal to r minus 1. Or, I'm writing it down, right? R minus 3 less than or equal to r, yeah. R minus 6 over 3 less than or equal to r plus 4. Is that the right setup? Yes?
It is.
Okay. So for a problem like this, Rich, what I would recommend doing is solving them completely separately and getting rid of your denominator start. So multiply the left side, or the left one, by 6 on both sides. Remembering to put that in parentheses. These cancel, giving you r minus 3 less than or equal to 6r minus 6. On the right side, multiply by 3 and 3. Cancel, cancel. This becomes 3r plus 12. And that r minus 6 is still there. Simplify, combine like terms. I'd probably move the r over and make this a 5r right here. I'd move the 6 over by adding it over to the left-hand side, making that a positive 3. See what I'm saying? You good so far?
Yeah, so far so good.
I'd move the r over on this side, making that a 2r. I'd move the 12 over, making that negative 18.
Yeah, that's how I got it.
And then I'd get 3/5. And I'd get negative 9 there.
Oh, I just had to divide.
Oh,
Yeah, that's it.
okay. No flipping of the sign needed, though, right? Notice that?
No.
The way I did it, actually, there's no flipping. Do you notice why I did that on purpose? I tried to keep my coefficient of r positive, so later I wouldn't have to flip the sign. That's why I moved this over to start the problem, make that positive. I moved this over to make that positive, so it starts the problem with positive coefficients for r. Now, what's the answer look like, though, guys? Come on, help me out with this one, because this one's a little tricky. R is greater than or equal to negative 9, or r is greater than or equal to 3/5.
I'll tell you the answer.
Which one is it?
What's the left one?
It's this one you're saying? Oops, I can't circle.
Yeah.
It's this one?
R is that equals to or greater than 0.6.
Yeah, is it?
Yeah,
What's your reasoning?
because because negative 9 is less than or equal to r, and everything 0.6 is less than or equal to r, and more. So you just use the left side because like look at this is look.
Yeah, but you're answering with an and statement right now.
They don't. Oh wait, shit.
It's an or statement.
It is.
Everything more than 0.6 is
Oh wait, I
negative,
messed up. No.
right?
It's everything greater than negative 9.
Yeah.
Everything greater than negative 9 includes everything that's greater than.
Yeah, it's either one answer or the other, right? The word or means that the solution is either this or this. Doesn't this already encompass all of this?
I guess so.
It does. And if it's one or the other, it could be that. It could be that one. So watch. Ready? Let me graph on a number line. Look, here's one answer, and here's the other answer. And what you did, Luke, was you looked at this as an and statement and said, where do they overlap? And you answered the question when it's an and statement, they would both overlap from here on. So if this was an and statement, that's correct. It's not. It's an or statement. For an or statement, this problem literally says r is either greater than negative 9 or it's greater than 0.6. But everything greater than 9, the negative 9 is already greater than 0.6. It's one or the other in this case. This will encompass all of those values that'll be in there. Okay, so greater than negative 9.
You should never, or statement is always, like, there's no, like, one answer. Always.
You have to interpret what's going on there, yeah. You have to look at the problem and say to yourself, well, if I think it could be this or this, if I just answer with this one, it already includes that, and it's one or the other, it could be either of them. So by answering with just one of them, simply this is enough information to cover both. Again, an and statement is where you're looking for the overlap. Okay, the overlap of two sets is where the and statement would come into play. And this actually is a good example of a problem that could have been written with the word and instead of or. Right? This problem could have been written with the word and the whole way down you have the word and then when is r greater than -9 and greater than 0.6? Only everything greater than 0.6 is that case. But if it's or, it's either of the two, which really encompasses just this over. Okay? All right. Word problems. Let's go to word problems. Problem set questions. Word problems. Problem set questions. The rest were easy, or?
Can we just go through like a couple of different types?
Sure. You want to do inequality word problems? So we get kind of killed two birds with one stone. We have an inequality and a word problem both. That
By
good,
types,
Ben?
I mean like speed or income.
Say again?
By types of word problems, I mean like speed problems or
Okay.
income problems.
That works. Let's take a look at. Here you go. Page 71, number 10. I don't think you did this one. It has to do with an equilateral triangle. Does that ring a bell or no? I don't think you did this one as a homework or anything. That's why.
No, I think we did.
It says the three sides, page 71, number 10. It says the three sides of. By the way, you know I put chapter 2 in your Google Drive. You saw?
Oh yeah, we did this one.
Okay. If you want to open that in iBooks, you can open that in iBooks so you have it. We did this already for homework. Okay. I just want to draw the diagram so you can see what's happening here for an inequality. The three sides of an equilateral triangle, so I start with equilateral, are increased by 20, 30, and 40 respectively. So now the new triangle's got a weird shape. This one's a little bit bigger, this one's even more big, and this one's even bigger at the end here. So this might be x plus 20, x plus 30, and x plus 40. Okay, originally it was an equilateral triangle, which is x, x, x. Now it says that the perimeter of the resulting triangle is between twice and 3 times the perimeter of the original triangle. What does that mean? What does that mean?
So 2x, 2 times 3x.
Not 2 times 3x. Not 2 times 3x.
Oh wait, what number was it?
Oh, wait.
This is number 10 on page 71. You may have done it for homework. You guys, don't look at your homework though. Do it again. Do it again if you don't. You should not have to go back to your homework and look at it at this point. The problem says the perimeter of the resulting triangle, on the right, is between twice and 3 times the perimeter of the original.
It's the last one for the problem sets.
Oh, it wasn't the problem sets?
So
Yeah,
it's an
it's
and problem.
I wrote that, well, first of all, I said that P1 is the first perimeter of the triangle, and P2 is the perimeter of the same triangle. And so then I did 2 times P1 is less than P2, which is greater than 3 times P1. And then I defined P1 and P2.
All right, hold on, because you're saying things wrong. You're making mistakes in your statements. Let's go back. So you have double the original. It's between twice and 3 times the original. So this is 3P1 here. Yeah, you said P2 again. So just be careful. So this is right. You're set. Let's describe. So again, the new perimeter of the new triangle, P2, which is this right here, is between twice the original and 3 times the original. Okay, between twice and 3 times the original. Now, does it say inclusively or exclusively? Let's see. It is between twice and 3 times the perimeter of the original. So it really doesn't give you enough information to use less than or equal to. So I wouldn't really take off points here if you chose either way. Okay, just so you know. Okay, it just says it's between those. Technically between does mean this. It should say including the endpoints if it really means that. Now, all you have to do at this point, this is what I think what you were saying, with 2 times 3, right? Yeah. So that's where you're going to use that. So this is going to be 2 times the original perimeter. Gotcha. 3 times the original perimeter. And that's going to be between those two values. And then you would solve this one. Okay? You want to do one with speed and distance, you said? All right, here we go. Let's try this one then. Well, actually, tell me, did you do numbers 12 or 13? For the problem set or the homework? Oh, sorry, section 2.3. Section 2.3, did you do 12 or 13 already?
No.
Neither of them? All right, so let's start with 12. Let's start with 12. I need to blow my nose. Can anybody have the book open? Can they read number 12 real quick?
Oh, I can
You got it?
Yeah.
Yeah.
During the first 20 minutes of the 50-mile bicycle race, Roger's average speed was 16 miles per hour. What must his average speed be during the remainder of the race if he is to finish the race in less than 2.5 hours?
In less than 2.5 hours. In less than 2.5 hours. So right away you think inequality. Inequality comes from the fact that it says less than 2.5 hours. So let's start giving information. We did a problem like actually similar in your lecture, right? In your video when you're watching. I think there was a problem very much like this. During the first 20 miles of a 50-mile race. Agreed so far? I do 20 and 30. It makes sense to write that way. Roger's average speed was 16 miles per hour. What must his average speed be during the remainder of the race if he is to finish the race in less than 2.5 hours? So, if you need to finish in 2.5 hours, you need to find the time it takes to do the first part, the time it takes to do the second part, and then do what to those numbers?
Make it, or at least 2.5 hours.
Less than
Less
2.5
than.
hours. Not at least. At least means greater than, right?
Oh.
Be careful. At least. If I said you have at least $5, you have $5 or more, don't you?
Yeah.
So this is at most, you want to use the word, okay? So we want to add the times together and make it at most 2.5 hours. So do exactly what we did a moment ago with the time equation. We did that earlier. Solve for time in this formula. Time is simply distance over rate. So I've got my first distance, 20 miles, over a rate of 16. So far, so good? So if it's not clear, let me just make sure it is. So you've got, again, T1 plus T2 must be less than the total time, which is 2.5 hours. So the first time it takes, again, is going to be D1 over R1. That comes from here. D1 is 20, R1 is 16. The second time, or the second portion, is D2 over R2. R2 is unknown. And that has to be less than 2.5 hours. So this is the problem you have for this. Not too difficult. If I want to get rid of R, I multiply everything by R. So multiply by R2, 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 R2. I want to get rid of 16, I multiply by that. So let's multiply everything by 16R2. Notice what I'm doing. I do this a lot with least common denominators. Multiply through. It clears everything out. 16R2 has to get distributed to both of these. The 16s cancel, right? This 16 cancels with this 16, making this R2 times 20, really. Here, R2 cancels with R2, making this 16 times 30. What is that going to give me? 16 times 30. 16 times 3 is 48. 480. Use your mental math there. 2.5 times 16 times R2. Well, 2 times 16 is 32. Half of that is 8. So I'm going to get 40 R2. And then go ahead and solve. Okay? Yeah, notice what's going to happen here. Your answer. Can somebody give me what they got as an answer? What did you get as an answer? Because when you move R2 over, you're going to move it over. So it's going to look like this now. This is what's interesting. Is that correct? Check your answers, please. See if it's correct. Why is the answer now greater than? We want the time to be less than 2.5 hours, but I have a greater than statement as my answer. What the heck's going on there? Explain. Explain, Max.
In order to get the correct speed to finish in 2.5 hours, you need to go greater than.
Yeah, because what do you know about speed and time? They are what? No, what's the word for that? Inversely related. If you spend more time, you're going at a lower speed. So if you want to spend less time, meaning less than 2.5 hours, your speed needs to be greater than some quantity. So it has to be greater than 24 miles. I think it was 24 in the end. I honestly don't know what the answer was. Let's say 24, okay? Has to be greater than. Now, technically, if you want to be less than 2.5 hours, it's simply greater than. If it had been less than or equal to, it'd be greater than or equal to also. Okay? Tonight, practice problems. Look in sections 2, 3, and 1, 9 for word problems. That's where I recommend looking. And the rest of this test, you guys should be pretty solid with. look over your examples from the lecture notes. Look at the problem set solution. I'll put that on Moodle. Put that in problem sets. Go to problem sets. You see problem set 2 solution. Okay? I have the next couple periods off, so if you need a quick question, want to come by, 4, 5, and 6, I'm up here. So come by if you need to.
Okay.
I got you ready.
You got this?
Yep.
Okay. Double checking.
Yep.